Alright, gang, so the Chapter 2 sample test starts off with this question, which just wants you to graph that linear equation. So you should be able to recognize this as already being in y equals mx plus b form. Remember, as a general rule, to graph linear equations, the quickest way is probably to make sure it's in mx plus b form. So in this case, our m, which is always in front of the x, is 2. Okay? And you better know that m is your slope. Okay? So slope is best as a fraction, especially when you go to actually graph something. And so 2 as a full fraction would just be 2 over 1. You always put the integer over 1 if you need to. If it's already a fraction, then it's already a fraction. And then your b value, this might be one of the tricky parts of this particular example, but our b value is actually 0. So the full coordinates of that would be, obviously 0, comma 0. So let's just... So there would be our y-intercept. So again, you always begin with b, then you move with m. So you plot the y-intercept at 0, and then you use the slope to get some more points, at least one other point. So from the y-intercept, you go up 2 over 1, up 2 over 1, maybe even go in the other direction for a point or two. I mean, really, you only ever really need 2 points, but so that's number 1. Number 2 is basically the same problem. They want you to graph this, but in this one you would recognize that you need to do a little bit of work before you actually draw your line. You need to do some work to actually put it in y equals mx plus b form so that you know what m is and you know what b is, so you can graph that. This essentially means you're going to solve for y. So I think I just kind of rewrote down the original over here where you have room to work your way down. And so the first thing I would do is I would move this term to the other side by adding x to both sides. That leaves 2y left over on this side. And then over here, remember, if we want to have it be like literally perfectly matching y equals mx plus b form, we're going to put the x term before this constant term. So instead of saying that this is negative 8 plus x, I'm going to write it as x minus 8. And then it's time to divide both sides by 2 to finish getting y by itself. And never forget that you have to divide both of these terms by 2 over here. Now this term is technically a 1x, and so you're doing really 1 divided by 2, which is not clean division, and it doesn't even like reduce, but remember, having this end up being a fraction is actually kind of ideal, because this is going to be our m value, which is our slope, and slope is great as a fraction. So it looks like our slope is 1/2, but remember, we always begin with b, the y-intercept. And so that's going to be at, negative 4. Okay? And then our slope is 1 over 2. Positive 1 rise, positive 2 run. And, you know, the more points you plot, the nicer looking your line is going to be, right? And then you just connect the dots, and again, 2 points will technically do the job, but number 3, write the slope-intercept form equation of the line that has this slope and contains the point -6, 2. So kind of changing gears here. Now we have to come up with the equation. They're telling us what our slope is, and they're telling us a point. Now those two ingredients, like those two givens, those suit this formula perfectly. Remember, you probably remember that this formula is literally called point slope form. Get it? Point slope form. Like, that's the exact ingredients that you would like throw into this formula, and you would have yourself an equation. Now, I know you might be thinking, but they want the slope-intercept form. And slope-intercept form is y equals mx plus b. Well, as I always say, whatever the final answer they want, however they want the final answer to look like, whatever form they want the final answer to be in, you don't have to start in that form. If what they're giving you is a point and a slope, feel more than free. In fact, this is what I recommend. Use this formula to build your equation. And so remember, the slope is going to get plugged in for m, and then the coordinates of this random point, any point, is going to go in for the x1 as well as the y1. So, obviously 1/3 goes in for m, the -6 goes in for x sub 1, the 2 goes in for y sub 1, and nothing goes in for x and y, because linear equations have to have an x variable and a y variable. So this x stays x, this y stays y. So notice how I'm keeping track of my negatives. There's a minus sign here already built into the formula, and x1 itself is -6. So this becomes a +6, and then you would have to keep this going, okay, to finish off in slope-intercept form, which is essentially, when you have it solved for y, and the other side is going to be mx plus b, something x plus something. So here the next thing you would do is you would distribute the 1/3. You would distribute the 1/3, and this side would end up being 1/3 x plus 2. 1/3 x plus 2. And then you would have to move this term, this -2, to the other side by adding it. And so since you already have a +2 over here after doing 1/3 times 6, when you add this 2 over, you end up with a +4. So this is your final answer to number 3. And I'm not going to give this too much attention, but just feel more than free to completely ignore all this stuff in blue. But if you happen to really like this method instead and you understand it, here's the proper work for the other strategy, which of course leads to the very same final answer. All right. This number 4, oh my gosh, this is something you gotta use to your advantage. That number 4 is very, 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 very similar to number 3. It just depends on what they're giving you to use. And this is also a minor plot twist that they want the final answer to be in standard form. But we'll get to that in a sec, because again, like I said, You don't start in standard form, you just have to make sure you finish in standard form. So what are they giving you? They're giving you 2 points. 2 points. Now you're probably thinking to yourself, it would have been nice to have what they had in number 3. In number 3, what they gave us was a point, and they gave us the slope. It would be nice if we knew those 2 things, because then we could use, shoot. Well, then we could use, I thought I was going to see this. It would be nice if we could use this formula again. Well, why can't we? We just need to know what m is, right? That's what we need to know. See, we have 2 points. We can pick one of these. Pick whatever one you want to use for your x1, y1. But what you need to know is m. But why can't we just use the fact that we have 2 points to figure out m? And that's what you do. First you find m, and it turns out that m is exactly 4. And now, oh, there it is. And now you know enough to plug in for this formula. Okay? You're obviously going to pick 4, or not pick 4, but you're going to, plug in 4 for m. And you can pick either one of these to plug in for your x1 and y1. I don't want to even bet what I did. I'm going to say I chose this couple of coordinates because in this formula, remember, this formula was technically y2 minus y1 all over x2 minus x1. And if we were calling, 1 and negative 1, if we were already calling it our x1 and our y1, I bet I just kept going with that. Again, see, you get it? We were already calling these 2 coordinates our x1 and our y1, so why not just keep that going, right? Even though, like I've been saying, if you want to choose this other point to use instead, knock yourself out. And so you plug into this formula. Now, we want this to finish off in standard form. So I'm going to do my best to kind of write neatly. This ends up being just y plus 1 because minus minus is plus. Over here we get 4x minus 4. Okay? 4x minus 4 when we distribute. Now remember, standard form is, ax plus by equals c. Essentially, standard form is you have your x term followed by your y term on the left, and then of course your equal sign, and then on the other side you have your regular number constant. Okay? And there are some fine print details about standard form, such as you're not really supposed to have a fraction as any number there. You're not supposed to really have a fraction, and you are, see, here's what I have. So I moved the 4x term to the other side. Of course, I'd have to do that by subtraction. Okay, so I minused 4x over to the other side. And then, of course, you'd have to move this term over here to combine with the negative 4. So you would subtract 1 over here, and that's how you'd end up with a negative 5. Now, like I was saying, this is more likely than not even your bestest answer. Because this leading x term is not supposed to be negative. I mean, I don't see a problem with it, and I don't even know if it's a in stone, rule that you cannot break. I don't know if it's an unbreakable rule that this number here leading off cannot be negative. But if you give an answer that's even better than this, I might give you bonus points. That's probably a thing that I still do. So the better answer, you might want to make a note of this, the better answer would be positive 4x minus y equals positive 5, which you can think of getting that as because you like divided both sides by -1, or you, same thing, multiplied both sides by -1. So again, the even better answer, which may get you bonus points in all likelihood, positive 4x minus y equals positive 5. Because again, standard form, you're not really supposed to have any fractions going on, and this leading coefficient of x is not really supposed, I mean, you're really not supposed to have fractions, but it's also pretty good manners not to have a leading coefficient here that is negative. Whatever. And if you like the other strategy here of building an equation, if this is your thing, here is the work, well, most of the work anyway, that you might have instead. Write the slope intercept. Again, we're going to build an equation based on what they give us. And once again, they're giving us a point. Oh, it would have been so nice if they would have given us the slope also. But wait a minute, they kind of sort of did. When they say that, your line is to be parallel to this other line from this equation, they are basically giving you m. You just got to do a little bit of work, okay? You have to analyze this other equation for what its m is going to be, its slope. Because what does parallel mean, people? You should know this for this exam. Parallel means what? As far as like equations and lines and slopes, two lines that are parallel have exactly the same slope. So in other words, whatever this equation's slope is, we're going to use that exact same slope for our equation. So once again, we're just going to use this formula. We already know that -1 is going in for y1 and 4 is going in for x1. But now that we've done this work in ruby red over here, now we know that we're going to take this same slope and plug it in for m. See? The only reason we need this equation over here is for its slope, because we're going to plug it in to our equation. And like I've been doing, I actually went all the way here. So obviously because again our final answer needs to be in slope-intercept form. And so this was really a +1. You distribute to clear the bubble, which gets you to here. And then you just got to finish getting y by itself to put it, to make sure it finishes off in this form. And, since you're subtracting 1 from both sides, you get this. And you're done. And once again, if you like this strategy instead, I'm not a huge fan. I mean, whatever. I guess I'm impartial to it. But if you happen to be way more comfortable with these steps, it's more than one way to skin the cat, I guess. But either way, again, please understand this. Either way, you're supposed to get this final answer. Number 6, identify the slope of the line perpendicular to this line. Okay, so if the line was going to be parallel to this, we would just go with the exact same slope. But perpendicular means something different. If two lines are perpendicular, their slopes are opposites and reciprocals, or as I say, refliprical. So, you would say like they're opposite reciprocals of each other. So you would take the opposite sign. So this slope is -2/5, which means the line perpendicular to this one, and you might want to write this down if you're still a little fuzzy, on remembering it, that you're going to take that perpendicular means opposite reciprocal, and that would make the final answer positive 5/2. Compare that to -2/5. The answer here is positive 5/2. In number 7, you have to understand that this and this, these two equations are very, very special, very, I don't want to say unique, but like it's like their own case, right? It's like a special case of linear equations because this equation only has a y variable and this equation only has an x variable, and this might be where you remember the trick of Hoivux, okay? Where this helps you remember that horizontal lines have a slope equal to 0, and the equations only have the y variable, just like 7a. So this is now, we know, is a horizontal line in the plane, and therefore the slope is what they ultimately want here. The slope equals 0, okay? So that's not really an O per se, it's a 0 over here in Hoivux. And, you know, as far as x equals 4, vertical lines, V, have an undefined slope. The slope is undefined. In other words, undefined, aka no slope, aka slope doesn't exist. Okay? So vertical lines, I'll just kind of repeat a couple things here. Vertical lines, I'll address the x here, have equations that only have an x variable, and the slopes are undefined. So if you would have written undefined here, perfectly correct. If you would have written no slope like I did, obviously correct. You also could have written slope doesn't exist, like the slope is d and e or something, or whatever. Does not exist. Okay? So you got to remember which is which. Okay? Hoivux. As far as the number 8, man, this is covering a wide array of of algebra concepts. This is a big exam, you know, chapter 2. It's covering a lot of different algebra concepts. Like here, number 8, they want you to identify the intercepts. I'll start with the y-intercept. You know, what you could do, and what you may have done, is thought to yourself, hey, isn't the b in y equals mx plus b, that b is the y-intercept. So why don't I just solve this for y, and I will know what the y-intercept is? And that may be what you did, and you'd be perfectly correct. That's fine. But there's also this way. Okay, to figure out the y-intercept, there's another way. You can plug in what for what. Plug in what for x. Obviously, we're plugging it in. What would you plug in for x to flush out what the y-intercept is? You'd plug in 0. That'll work. If you plug in 0 for x, it'll reveal, and then you just solve for y. So this is gone. Negative 3 times 0 is just 0. So you end up with 5y equals 15. Divide both sides by 5, and you get 3. So the y-intercept is 3. Technically 0, 3, the full coordinates. And likewise, you can do the same but opposite to find the x-intercept. You can plug in 0 for y. Plug in 0 for y, it'll flush out the x-intercept. And it's easy because 5 times 0 is 0. So this becomes negative 3x equals 15. Divide both sides by negative 3. And you have negative 5, which in full coordinates is negative 5, 0. Now, you don't need to write down what's in purple. You know, like if you say the y-intercept is 3, people are going to know what you're talking about. You know, you don't need to say 0, 3. You know, if the y-intercept is 3, then that is 1 point all by itself, and so boom, bam. And then the x-intercept is negative 5, so you just plot it on the x-axis, and then you connect them with a line, and you're done and dusted. Number 9, 10, and 11 talk about domain and range and whether or not it is a function. All right, why don't we start with number 10, just because it's As far as a progression here in level of difficulty, number 10 is the easiest because as far as domain goes, you have to remember on this exam, the Keystone exam, future math classes, these vocabulary words are pretty huge. Domain is all of the x values, and the range is all of the y values. So every single one of these points that make this graph have its own x value. And so you just write those down. This dot had an x-coordinate of -6, -2, +1, +3, +4, and +6. Just like all those points had their own y values. This one had a y value of no, this one had a, I guess I started here. So this one had a y value of -3. Both of these dots had a y coordinate of 0. You only need to write it once. Only need to write it once. This had a y coordinate of 2, 3, and 4. And whether or not a graph represents a function, and you might want to write this down, this is where you can do the vertical line test. Why don't I just go ahead and I don't know, let's go with green, whatever. So remember, the vertical line test says if you can draw a vertical line anywhere or slide a vertical line across your graph, and if it only ever hits your graph once, then it passes the vertical line test. And so that's why this is a yes, because a vertical line will never hit this graph in more than one place. But this guy over here, I mean, look at this. It's hitting it twice all over the place. You know, like everywhere I slide this, see, like this, it's hitting it twice, right there and right there. I mean, and all it takes is one to fail, but you know, this is like hitting it twice in like an infinite number of spots. So that's why this is a no. And then what about this graph over here? Does this pass the vertical line test? No, it's hitting the graph twice in basically from like here forever to the right. But so that's a no. Okay. And by the way, graphs like this, if I moved a dot or two in a different spot, I could make a graph like this be a no. Okay. And if this was a regular looking V, just like a right side up V, then it would actually be a yes. It would pass the vertical line test. Now, domain and range of number 9 and number 11. See here, the fact that you got to remember that there's like an infinite number of dots on this graph. So there's like technically an infinite number of x coordinates and an infinite number of y coordinates. So we just have to kind of give these answers in intervals where we kind of say, well, the smallest x coordinate would be this and the largest x coordinate would be this, you know, or there is no smallest x coordinate, or there is no largest x coordinate, smallest coordinate or largest, because you know it goes on forever or something. So as far as x coordinates here, the graph never goes any more left than this point right here, which has an x coordinate of -2. But it goes to the right forever. There is no largest x coordinate. Whoa, what in the incorrectness? Did I do that on purpose? To give you a chance for bonus? Yeah, you never have a bracket on infinity or negative infinity. Because remember, brackets mean you are including that number in your set, and parentheses mean you are not including that number in your set, like you're not that boundary. So yes, another way to say this answer would be all x coordinates greater than or equal to -2. So there's more than one way to give this answer. And then as far as the range goes, there is no absolute lowest point, and there is no absolute highest. It goes down forever and it goes up forever, and there's no restriction at all on all the y coordinates. Here, as far as like left to right, -5, +5, and literally every number in between. So that's why we give an interval, okay, from -5 to +5. And the range, the lowest it goes is a point that is -2 with the y, and the highest this graph goes is a point that has 2 as its y coordinate. And again, everything in between. Ooh, these are even easier because, man, number 12 and number 13, the domain, again, the domain is all of the x's. They're just and remember, you don't have to write down the same one more than once if that is the case. And the range is all the y's. Number 13, it's literally 2 columns separated for you. So there you go. And something you might want to write down, in these situations, the quick, easy way you can tell whether or not it's a function is if there's any repeat x's. A function is not allowed to have any repeat x's. So are we repeating? It doesn't look like we are repeating in number 12, so this should be yes, it is a function. But, oh, look at this. That's not allowed, so that is not a function, because a function, if you input something, every input is only supposed to have one output. See, you can't have -1 as an input matching up or mapping or whatever to both a 3 and a 0. So number 13 is not a function. You just got to look for whether or not there's repeat x's. Changing gears again. This test is insane. But number 14 is not that crazy. Find the slope of the... That's all they want. That's all they want is the slope. Read the directions, people, okay? And to do that, see I have these red dots. You're going to want to locate a couple of nice points on your line. So you can either just count your rise and your run, or I guess you could throw this into a formula, like take these coordinates and maybe those coordinates, or pick any two here really, and throw those coordinates into the slope formula. But all I really did here was go, okay, from here to there, right? Or what did I do? Yeah, I just went like 2 dots that were close together. Down 3, that's a rise of -3, and then we went to the right 1, which is +1. Remember, its slope is rise over run. And if this was your final answer, I probably wouldn't punish you, but like -3 over 1 is just -3. Okay? Now, whoa, doggy. That's crazy. Okay, just getting ready here to do number 15. So number 15 you have to recognize as a linear inequality. Why is that not locked down? So remember the steps of graphing a linear inequality. You're going to graph the line, okay, like as if this was y equals -3x plus 4. You're going to graph the line, but since this is a greater than, okay, or it's an inequality, your line may have to be drawn as dashed. And you have remind yourself by writing down like what symbol means what. Because you got to remember that a symbol like this, when it's just strictly greater than and not greater than or equal to, this is going to end up being a dashed line. So the good news is this is already in mx plus b form, so I know that my y-intercept is +4. and I know my slope, my m, is -3, which really means -3/1. Hey, just like here. Oh my gosh, this is the same line. Wow, that was not on purpose. It's the same exact line, but it's going to be dashed. That was, ooh, I promise you that's a weird coincidence. So, I mean, right? Y-intercept of 4, -3/1, boom, bam. And remember, we already sort of, what in the holy crap? That makes me think of Super Mario, like Giant Land or something. So it's a dash line. And what else, people? What else do we need in a graph of a linear inequality? We need shading. And remember how to do the shading? You could do a test point, and looks like 0, 0 is available to test. But the quicker way is just look at the symbol. It's a greater than, which means we shade up. We shade above. Man, doing this with a mouse is not ideal. Anyway, there we go. Next problem. Again, it's like you got to be on your toes here about this is a linear inequality. This is an absolute value equation. And what that means is your graph is going to be a V. Absolute value of x involved. Your graph is going to be a V. It's an equation, so you don't need to worry about any shading or any dashed lines or whatever. You just got to look at this and go, all right, my parent function, when you compare to this, you know, we got this -1 that would move the parent graph down 1, and this 2 out in front would affect the slopes of your lines. In fact, it would be 2, like that. Excuse me. That number 2 would actually be the slope of your lines. Okay. So again, whoa, what in the heck and heck? Magic. Anyway, so my vertex would move down 1, and since there's nothing added or subtracted directly on the x, then there is no shifting left or right from the parent function. So this is my vertex, and then because 2 would be like my slopes, that's 2/1, up to right 1, but like in both directions, so also up to left 1. And why not do it again? And why not even do it again? Alright. And I hope I got that. Nope, I screwed it up. It's this guy. And then of course you would draw your V, and you're done. Because you have to know when there is shading, when there's not shading, when it's a V, when it's just a line. You know, you got to know all this stuff. Okay? And I guess in number 16's case, once you realize it is a V, and it's just going to be a solid V and no shading or anything because it's an equals, once you understand that, you have to remember the whole idea with like shifting up or down, left or right, potentially flipping your V upside down, or having a slope or slopes other than, you know, up 1/1. In this case, it was 2, up 2/1 in both directions. 17, 18, 19. So once again, ooh, number 17. Look at this. It's got absolute value, so it's going to be a V, and it's a less than. All right, it's a less than. I'm going to steal, I hope, well, I'm going to steal these points over. Whoa, baby, what the heck? Where'd that come from? That was weird. But, so here we go. We can draw the V, and we just got to know the whole time that eventually this V might end up being dashed, and there's going to be shading. Okay? So here we go. We have a shift down 2 because of that minus 2, but this plus 3 directly on the x is going to move it also left. Not right, left. So my vertex, which sort of starts off as a default at the origin, goes left 3 and down 2 because of the plus 3 here and the minus 2 there. And then this 1/2 way out in front, it's positive 1/2, so the v is going to stay right side up. But remember, this 1/2 is like literally my slope or slopes. So 1 over 2. So rise 1 over 2. In both directions. Up 1 over 2. Up 1 over 2. Up 1 over 2. And let's see here. Yeah. And so, yeah, well, I guess cat's out of the bag. I was going to ask you, so does this less than mean it's going to be dashed or solid? And it means dashed. And then, of course, it's an inequality, so we need to do shading. And this is a less than, which means we shade below. Right. Once again, you could also do a test point. And it looks like the easiest one is available, 0, 0. You know, and if so, here's a little like you know, to elaborate on this a little bit. If you were to throw 0, 0 in for x and y, it would make this statement not true because it looks like 0, 0 is not going to be a solution because it's not in the shading. Now number 18, look at this. Again, you got to know what you're looking at. In number 18, we're back to it being a linear inequality. There's no absolute value. This is just going to be a line. But since it's an inequality, it's going to be an either dashed or a solid line. And there's going to be shading. Extra plot twist in number 18 is, when you go to graph your line, it's not in the form we need it to be in. It's not solved for y. So in number 18, the first thing you got to do is solve for y. So now that I know that it's this, now I can graph my line. Okay, with a y-intercept of 4. So begin with B and move with M. This is a negative 2 over a positive 3. So down 2, right 3. Okay? And my line is going to be solid in this case because it's greater than or equal to. That's something you have to know. And the shading, well, again, we got to check down here. Remember, you got to check this symbol down here. And it's a greater than or equal to, so we shade above. Okay? Once again, if you like doing the test point, it looks like 0, 0 is available for easy checking. And you can see here pretty easily that if you plugged in 0 for x and 0 for y to check this point right here, you would end up with, is 0, this whole thing would be 0, is 0 greater than or equal to 12? No, 0 is not greater than or equal to 12. And so this point right here is not a solution, so you would shade the other side. Number 19. It's an absolute value equation. There's not going to be any shading. There's not going to be any dashed lines at all. Okay? But it is going to be a V. And so, remember how we like to do this. We look at how it compares to the parent function and its graph. And we have this minus 1 that's going to, you know, make a change, and we have a negative or a -1 way out in front. So the original vertex, the default would be here, but this -1 moves it where? To the right one space. And because there's nothing here, there is no shifting up or down. And then the -1 out here, that's going to basically be your slope or slopes. Negative, of course, meaning our v is going to be upside down. So -1 over 1, that's down 1 over 1 in both directions. Okay, and I have the points here, so I might as well use them. And I'll stop there. And again, this is an equals, so we don't need to do any like potential dashed, and there's not going to be any shading. And that's done now. Number 19 is done. All right, final stretch. Okay, it's been a long video. This is a big test and an important test, especially when you think about keystones and just future math classes and basically your really strong foundation in all this linear algebra. So number 20 and 21, they're literally like 2 more questions. Yeah, 20 and 21 have to do with scatter plots and coming up with the equation, maybe making a prediction. Wait, did I? I'm kind of surprised. Well, I'll tell you that in a minute. But at first, okay, you're supposed to come up with the oh, no. Then predict. I did do that. Sweet. All right, then predict. Okay, cool. So in number 20, we're going to do the equation, and then we're going to make a very easy prediction. In number 21, slightly different story. But in number 20, here's what we do. The very, very good news is that I already have the points plotted for you, but even better is I already have the line of best fit drawn for you. That's a very, very good thing. I already have this line of best fit, which makes it pretty clean and like it would by design. This hopefully ends up being like clean enough, because you should be able to look at this line and pick that, like when you pick a couple of points, you're picking like either that one along, this one, this one, this one, this one, like those are your choices, like those 5. Now, like I say, the farther apart you choose, that's just to go with a general rule of thumb. The farther apart, the better. So I'm going with my coordinates I'm using here in this work. And again, you might have chose differently, and that's okay. If you already did this sample test, which you should have, you should try. That's the usual routine. Is you try this sample test, and then you check these videos as needed. Okay, but it's okay if you chose a couple other points, but I chose 15, 50, which is technically 50,000, and 31, 70, which again is technically 70,000, but if I just go with 70 and 50. So I have 2 points. You get your slope of 5 over 4. Again, if you had 5,000 over 4, that's fine. And then you come up with this final equation probably. All right, and here, if you can see this, this would be like the other way to come up with the answer if you're more of this kind of person. But I like to use this formula, and this is essentially the equation you should get, or I think this. If you had this, because you were going by like 5,000 over 4, and therefore our y-intercept is 31,250. Whatever. Like this also works, but this is the equation. So that's part of your answer. And then as far as the prediction for 27 years, well, look, people, 27 is right here. Right here, okay? So you go, like, you can just kind of eyeball that on your line. So the other part of your answer here would be, looks like $65 or $65,000. Because look, it's right here on the line. It's right here in bounds. It's right here, 27 years. You can just kind of go up to your line and 65,000. So I think, yeah. Oh, I did it right here. Cool. So obviously, if you have your equation, okay, spoiler alert for number 21, but if you have your equation, you can like literally plug in the x value they're giving you, you know, or like I just said, or just look at the graph like I just sort of pointed out, no pun intended. But ultimately the answer is 65, which is $65,000. Okay? But for number 21, they're asking for 94 degrees, which is pretty far out of bounds. But not only that, if you have the equation given to you for free, you might as well use it, because 94 is literally an x value, a temperature x value. So you might as well just use that. See, this was my idea for number 21. Use what you're given. And if I'm giving you the equation, thank you very much, Mr. Falk. And, you know, plug in 94 in for x and just crunch these numbers, and you get 579 customers. You know? And I don't think that's anything. And that's it. You know, happy studying. Let me know if there's anything that didn't make any sense before we take this test.